So we're going to do a matched pairs problem. And in matched paired problems, we'll have two very similar pairs. For example, this Buick LaCrosse, we have essentially two of the same kind of car, and we're putting one type of gas into it here and another type of gas into it here and reporting the gas mileage. But in all ways, these two Buick LaCrosses should be very much alike when it comes to gas mileage. So it's a matched pair problem because the two things that we're using are very much alike. So we're going to use this data in this table to construct a point estimate and a 95% confidence interval for the difference in average fuel economy between cars operated on type 1 gasoline and cars operated on type 2. And notice down here we have a different confidence interval formula. And the big thing is this D bar and this S sub D. Well, these are really the mean and the standard deviation of this column that we're going to make called the difference. All right, so what we're going to do is take the difference between car 1's gas mileage and car 2's gas mileage and put it over here. So 17 minus 17, this difference is 0. Here we'll have 13.2 minus 12.9.3. And notice we're going from left to right every single time. So 35.3 minus 35.4 is negative 0.1 in this instance. 13.6 minus 13.2 is 0.4. 32.7 minus 32.5 is 0.2. This one will give us 0.3. This is 0 again. 0.1 and 0.1. Now we want to take this and copy and paste this column into Excel and find the mean and the standard deviation of this column. All right, so let's do that. So I've already copied this in. I've copied it in. This is actually C2, and down here is C10. So I'm going to start by finding the mean, average, equal average, C2 to C10. And there's our average. And then let's do, whoops, equals stand dev.s, C2 to C10. And there's my standard deviation. Okay, so 0.144444444. All right, we'll round this to maybe 3 decimal places. Actually, since our original difference is just 1 decimal, let's round it to 2.14 for our mean. All right, so we'll go back. Oops. All right, so our D bar is 0.14 plus and minus. Now we need to get T of alpha over 2. So let me kind of go down a little bit before we set up the rest of our confidence interval. All right, so we've got 1 minus 0.95 in our confidence is 0.05. We want to take that and divide it by 2, and that's going to give us 0.025. So we're going to put in 0.025, and if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, we're only going to count the number of pairs in this case. So the degrees of freedom are the number of pairs, 9 minus 1. So we have 8 degrees of freedom. So we're going to look up, using a T distribution, we're going to look up 0.025 with 8 degrees of freedom. So equal T dot INV 0.025, comma 8, and we get negative 2.306. And of course, since it's a confidence interval, we only care about 2.306. All right, so the T value we're going to use is 2.306. Now let's add everything in. We're going to have 2.306 times our standard deviation that we got back here. Now we do want to take that out further, 0.6666667. All right, so 0.1666667. So my standard deviation is 0.1667. divided by the square root of n. And of course, I said n in this instance is the number of pairs. So we don't want to count it as 18. We want to count it as there's 9 pairs here. So it's the square root of 9. All right, so let's work out that right-hand side first. I'll put 2.306 times 0.1666667 divided by the square root of 9 into my calculator. And I'll go ahead and round that to 2 decimal places, 0.14 plus and minus 0.13 when I round it to 2 decimal places. So we are going to get, let me scroll down just a little bit, 0.14 minus 0.13 is going to give us 0.01. And 0.14 plus 0.13 is going to give us 0.27. All right, so let's make our confidence statement. We are 95% confident the true difference in gas mileage is between 0.01 and 0.27 miles to the gallon. All right, and there we've got it.